Cesar, just let us know when when you would like us to begin.
Yeah,
Great.
thank you, Larry. I just turned the recording on. We're gonna be recording, so for anyone that was not able to get on the meeting, we can share it for future if that's okay.
That'll be excellent. That'll be excellent. We certainly appreciate everybody taking time from their busy schedules. I know to spend a little bit of time with us this afternoon. And Cesar, we appreciate you setting up the opportunity on your end.
Yes, no, absolutely. So welcome everybody. Good afternoon. I'm, pretty much everybody, you know me already. I'm Cesar Menendez. For those on the call that doesn't know me, I'm Director of Feed Manufacturing, Technical Support for Smithfield Foods. So I pretty much work with all the feed mills across United States. I do, some little support as well for our Mexico partners. And I work directly here based in our corporate office in Warsaw, North Carolina. I want to appreciate Better Raven for the time and being on the call today, but also for the opportunity for allowing us to get on the meeting today and also kind of understand and know more about Better Raven, but also I have multiple people from our company and as well from our engineering department to kind of also see what you guys had and also an opportunity for everybody in this call to ask some questions. I do want to say that we will if you see on your menu there is a chat menu, and I would like for you to pretty much write any questions that you may have on that chat menu. And between the call and probably about the middle of the call, we're going to do a quick stop and start answering some questions that have been sent to us, or you can text it to me, whatever way it works. Baltasar en dos en México, you can text it in Spanish. Tú me lo puedes escribir en español a mi teléfono o me lo escribes por WhatsApp. Yo lo voy a postear o se lo voy a dar a ellos en el momento correcto cuando ustedes tengan preguntas. So, again, for those in the call, thank you for your time. Larry, you want to get it started and then we'll go from there. So thank you.
Certainly. So my name is Larry Beck. I'm the general manager of Beta Raven and the CPM Automation Group. We very much appreciate not only the opportunity to talk with you all today about the automation system for your feed mills, but also to express our appreciation, I think, for a long-standing partnership with Smithfield, with the teams in Mexico as well, and certainly in Romania. On the call today, from a Beta Raven perspective, you have myself, Fred Olson. Many of you probably know Fred is our customer service manager, and he's quite a few years of experience with database and software engineering, so he manages that group. Chad Brenton is our engineering manager. Again, has been with us quite a few years, I believe about 10 years now. So Chad's very familiar with the technical aspects of our product, as well as going to highlight kind of some of the innovation and ongoing developments and engineering work that we're doing. Dennis Witt is your commercial sales manager for all of your projects from a corporate Smithfield account standpoint. I know we also have Jamie Smith on, who works with our customer service and works with Dennis, and Jamie's background actually came out of running a feed mill. He was a Beta Raven customer for quite a few years, so he's very familiar with the product, the capabilities, but also I think importantly to our team, very familiar with the operation of feed mills and the requirements in the industry. So he very much offers us a voice of the customer perspective, which is very valuable to us. So we've kind of put together, Chad's done a nice job coordinating activities on our end to put together just kind of a summary of not only the product, but some of the new developments, some of the features that we're working on. It is a ongoing product that we continue to invest and develop in as needs of the industry change, but also to provide tools to enable our customer partners to maximize their efficiency and their operational performance in their locations. And so we're kind of going to run through that. Dennis will talk to some of the history of the company as well, and the relationship that we have. This slide that Chad has, you can see that we are part of CPM, so it's a very large global platform that we are partners with. As you can see, from a Beta Raven perspective, we're located in the Midwest and right in St. Charles, Missouri. We also have now added a control system capability in the UK about 2 years ago that is part of my automation group. So we're able to, as we're expanding, we're able to take care of both the Americas as well as the European markets, and in conjunction certainly with CPM as customers have needs in Asia. But as you can see, it's a large company presence. We do automation activities with all of our sister businesses, as well as obviously for our core product and serving that the markets that we serve there. So Chad, if you want to go to the next slide. Again, kind of just from an agenda standpoint, Dennis will talk about Beta Raven, the qualifications. Chad will go through the design, project examples, software initiatives, hardware technology, HMI initiatives. And then Fred's going to actually run through a demo unit and show some of the features, Cesar, that you had requested information on in actual a live demo of the product, so that you can see the latest version of the technology. This should be representative of what we're putting in and recently sold up into the Algona mill that'll be starting up, as well as some of the more recent projects that we've worked with and partnered with Smithfield on. So that's kind of the agenda we want to run through. Certainly, I would echo Cesar, this is a meeting for your team. So as you have questions, please don't hesitate to use that chat function to ask those questions. That's what we're here to try to answer, as well as just share some of the activities, the innovation, the development that we have going on as a company, and certainly our endeavors to be a good partner to the industry and to the market.
Thank you, Larry. Just pretty quick, as thank you for introducing your people. Some very quick things here. Just please, for everybody on the call, we got over 33 people here on this call today. I want to ask you to, as you know, if there's no need to talk, please mute yourself. That's going to help improve a lot the quality of the sound. Larry, I do want to quick introduce, we got multiple people from feed milling across the country in Mexico, as I mentioned, but I also want to mention that we have Mark Powell in our call, also Dave Elking, who is our Director of Engineering, and who I Director of Report, and also Katie Elmer, which has been part of the critical continuous improvement process in the engineering support for our bakery side of the business. So I just want to briefly mention that, but appreciate you guys being on the call, and you guys take it over.
All right, thank you, and certainly welcome to all, and hopefully this is a good overview of the product and where we're going with it. So I'll turn that over to Dennis.
Cesar, I've had my phone muted. I'm calling in on the call-in number.
Dennis, we can hear you.
Yes, we can hear you, Dennis.
Okay, I'm trying to.
There was some problems today. Just a couple hours ago, we've been aware, or at least an hour ago, we were aware of Microsoft having issues with this platforms, include Skype and Outlook. So hopefully we don't have a major disruption, but I appreciate everybody patient. Dennis, are you there?
Chad?
I'll say if Dennis is having difficulties with his microphone, we can certainly walk through this as well. So, Chad, I don't know if you want to talk to that or if you want me to run through it for Dennis.
Yeah, I can run through if we need to. I think we keep getting the feedback from Dennis's call-in line.
Yeah, I think so. It might be easier to have both of those muted, Dennis.
Feel free to take off, Chad.
All right, so long history between Beta Raven and Smithfield. But Beta Raven itself is we've been doing the automation in the feed mill industry for over 50 years now. With the experience that we've with the people that have been working here, we've seen everything in the last 50 years that you can think of, but there, every year there's something new coming down that we're excited to tackle. We're really looking forward to anything that's hasn't even been thought of yet. And that is our strength is the technology aspect of what you guys are producing. We want to be the partner for you to make the technology that's coming out work for your system and improve your products. Let me go to the next one here.
Chad, can I be heard?
Yeah, there you go, Dennis. Oh. For a second.
If for X, Y reason you get muted, you can make sure you press *6 and that will unmute you and you should be able to talk back again.
Give Dennis another few seconds and then I'll just keep going. So I'll just keep going. So the advantages of what we feel are the advantages of our meeting him is we want to offer the best value with the package that we provide. Our reliability and supportability, I think, is what we emphasize the most, because we realize that your system needs to be running more and the most reliable system in the area for your product. So what sets us apart from our competitors, we feel, is our support, and we'll get into that a little bit later. But we also, the presence in the industry, we've got over 500 installed systems worldwide, as most of you know. We even have the installation with your partners in Romania that we support regularly as well. So we feel we're the most capable feed mill control system, and emphasis on the supportability of that. And so our capabilities it does go beyond the feed mill as well, though. With our partnership with CPM, we've gotten into things like extrusion, both plastic extrusion and food extrusion, some pet food. We've also gotten into the refining, oleochemical extraction, and also thermal processing with our Wolverine partners. So it's not just the feed mill, that we're focused on, and we get to use those other industries to bring in ideas to the feed mill industry for customers like yourself. So I want to kind of go through just some, our practice and how we approach a new project. First, all of our code, we heavily standardize all of the code that's running all of your feed mills. And we do this for the supportability that we want to achieve. Our goal is to be able to have any one of our engineers, whether they've touched, this customer or not, be able to wake up in the middle of the night, 2 or 3 a.m. in the morning, and be able to get online and quickly diagnose the problem that may be happening. And that the only way that happens is with the standardization that we've instilled in all of our new engineers, and our team here. And to go with that, we also have standard HMI layouts. So all the icons that we use are a library that everyone uses for every one of our customers. Now we're constantly improving those sorts of that library as well. but any one of our engineers should be able to get onto a customer of ours and be able to recognize the symbols that are on your screens. Now, the thing that sets us apart as well is we're always using the #1 hardware in the industry. A lot of this stuff is run on hardware that has been tested. It's with the good warranties from the manufacturer as well. So in the PLCs, we mainly use Allen Bradley, whether it's ControlLogix or CompactLogix, but we can also do Siemens as well. Our HMI software is actually for you guys has always been Ignition ever since Smithfield brought us the package and said, you should look at Ignition. It's really, we think it's a good product, and ever since then we've been using Ignition for everybody else that we can. And of course, our computer hardware is, I've got Dell listed on here, but for our networking hardware, we're using all Cisco products. So everything that's, highly regarded in the industry as a, reliable product. We've had these success stories with, a numerous amount of customers throughout, both the United States, but also worldwide. So our team here in St. Charles, we're made up of about 20 PLC programmers, and those same people are also going, to your facilities and starting up the projects. We have a dedicated team of about 4 people here for service, and they're on call 24/7. We have 2 in-house network engineers now. We added one to, most of you know Dave Kunzman, but we've added Jordan Sparling has moved over from PLC programmers and to network engineering. And we also have our database team. You guys have all talked to Fred or Christopher in the support of the Millmaster product. And then we have a team of people that are designing our electrical panels and building our electrical, our control panels as well. For our technical support, this is where we really try to shine. We have the phone number for our 24/7, 365-day support. Whether it's a holiday, a vacation, we've got somebody here on that can support your facility. And the only way we can really do that is with the VPN access, that you guys provide us and every one of our customers provide us. Without that, remote access, we wouldn't be able to, give the superior support that we're looking for. Earlier this year, we did implement a new system. Some of you might have seen it, but we have a ticketing system for our, anytime you guys call in, we start a ticket in our system, and that way we can track any open items and see any, past notes of what has happened with that customer, with that ticket before. So we think it's really improved our service there, and it also gives you guys the visibility into what we're doing because you're copied on all those tickets that we create. So I know some of the, the domestic mill managers are on this call, and I'm sure they've seen tickets for, their feed mills. So since we're also talking about a brand new facility on this call, we kind of wanted to go down a project procedure of how we tackle that. So initially, what we're looking for is that flow diagram. And that usually is pretty well established at the bidding process of any new construction project. And what we do is we take that flow diagram and turn it into our equipment list. And this becomes, the emphasis of everything that we do, from the quoting to the design all the way through startup. Our equipment list is the center of everything that we do here internally and externally as a communication to the customer. And with that, we can do all the quoting and the design and even the programming with that. We also, try to go over any control schemes that might be different for a project. Most of them we understand, just being in the feed mill industry for so long, we can kind of just look at a flow diagram and get it. But every now and then we want to just do a review on any new piece of equipment that we may not have seen before, or maybe there's, a customer specific control narrative that they would want to achieve. So we want to go through that as well. So after then we submit the quote to you as the customer, and then move through the procedure of the equipment list approval and designing HMIs. And then any timelines, it will be the next thing is, we need a project timeline that meets your needs so we can make sure that we're achieving those milestones of HMI approvals, equipment list approvals, shipping the panels, for the right phase of the construction project, to make sure that, everyone has a successful project. And then a project manager is the one that also is your main point of contact, but he's also the one that's going to be doing all the PLC programming, HMI programming, and the person that is going to come to your facility to, start up the equipment. So that model for us is really important because we feel like that same person gets to know the project all the way through, and there's nothing left off in a handoff procedure where the programmer stays here and then a technician goes and starts up the system, who's always on the phone with the engineer back at home base. So once the order is entered into our system, we create our electronic project folder on our side, and that's where all the documentation is stored for all of our internal and external communications for that project. The number one task once it's an order is to get the equipment list approved. And some of you have gone through that procedure with us as well, but we just can't stress enough how vitally important the equipment list is to us, to make sure nothing is missed in both the design side and when we build the electrical panels. And if everything goes perfectly, we don't have to make any field changes, but the equipment list is centered to all that for us. And then when we get to the startup procedure, first we want to verify and set up the network. We'll be talking about the network a little bit later too as well, but the network in these modern facilities is the most important backbone of everything that's going on in the facility. With a network that fails a lot, you get a lot of processes that fall down. But once we make sure the network is set up and verified, then we check all the IO in the entire facility, validate the programming for anything that we talked about, during the design phase. Once everything's verified, we train the people on site to make sure they know how to run the system, and then we want to make sure that we have the right amount of people on your facility to start up in a timely manner. So we've done, I think the most we've done on site at once has been 4 people for a 24-hour shift, but it's all project dependent on, and also for your timeline purposes. So speaking of the network, this is the system layout that we deliver and we keep up to date for every one of our customers. This is the current system layout for Granhaus. And you can see, there's quite a few networking components that are involved in this facility, and that's why the network is so important for everything on the automation system. For the new building that we're hoping to automate as well, this is kind of what we're going off of for the quoting phase as the system layout. And so you can see, a bigger facility, newer facility, even more Ethernet devices that are on there. So all the more reason to make it a critical part of the design process. And we're about to start up, do a big conversion at the Smithfield Algona facility. And so this is the system layout for that as well. Before we get off this slide, I want to highlight the break room workstation here. This has kind of been a Smithfield only, and we really like it, but what we've done is Smithfield provides a very large TV or monitor in the break room, and we can put every piece of equipment onto one sheet in the break room for you guys. So when you're in there having lunch or whatever you're doing, you can look up and see if any of the equipment is faulted or make sure everything is running as well. And with that, we've also developed a few dashboards for the various Smithfield locations, where you can have some, quick reports or quick views of how the system is running at a more of a managerial level instead of an operations level. Here's a close-up view of just one of the sections of that report. So in a new facility, one of the things we always want to look at is a control room towards the end. I've just got a few examples of control rooms we've done recently, just to spark your imagination. But here's one where the control room was set up with 6 individual monitors, on stands. But we also have a new product that we've been offering lately where it's a 43-inch 4K monitor, And the monitor itself is actually 4 monitors. You just don't even see the interaction between the monitors. So it's a good way to save some space if you need to. But here's a closer look, and you can see that it's 4 separate windows that are actually one. Looks like one device as a monitor, but it's actually 4 monitors. So one of the other parts that we provide as part of the automation system is the industrial control panels with the electrical components. And just as important as the network is the ability for us to provide a good place for the field wiring to land. And our design practices for every industrial control panel that we do is we want room for future IO. The project is a snapshot in time, but as we all know, things change, equipment's added, removed. So we want to make sure that you're not boxed in to the equipment that you have, and we've got room for other things. Part of my emphasis on the network is we need a managed switch everywhere we can, so we can shape that network traffic to make sure that we're being the most efficient and most reliable for the whole system. An industrial UPS, this is for unclean power. For a new facility, we typically do a consolidated UPS that's in the break room for the entire building. But for retrofits or installs for an existing facility, we include uninterruptible power supplies in every one of our panels, just to make sure that there's clean, good power going to the sensitive electronics. And our IO is segregated into production areas. A lot of our competitors will mix and match IO into various components. So if you lose one piece of equipment or one electrical component, you actually can take down multiple areas in your mill, where we separate the IO and make sure that if something does go wrong, the rest of the mill isn't affected. And to kind of double on that, we also use multiple processors that are dedicated to specific production areas. So if something were to go wrong with that processor, we're not taking down the entire facility as well. So just part of our key design criteria for the electrical panels is also keeping uptime in mind. A lot of people don't know this, but we also build motor control panels. This one was for an extraction facility, and it's one of the ones we're pretty proud of, but it's 74 motors are run out of this 3-door panel. We just like it as a sales tool, but it's something to keep in mind that we're not just in the IO game. We can do motor control as well. And I'll kind of also touch on that a little bit later. To move away from brand new facilities, a lot of the projects that we do throughout the year are upgrades or retrofits. And so this was a panel that we encountered that they wanted to obviously clean this up, just a little bit closer view. This is what the electricians were dealing with to try to figure out if something went wrong. Very, very difficult to figure out and troubleshoot if something were ever to go wrong. So after our upgrade, this is what that same panel looked like. Much cleaner. All the IO was cleaned up. Everything moved to terminal blocks that were landed and clean and labeled. Makes for maintenance a much easier task. So just to, as you guys are, to select a control system or an automation vendor, you want to make sure that your panels have room for expansion. We segregate the IO. We do an estimated pricing for anything future. If there's going to be a future 3rd pellet line, we can certainly give budgetary pricing for something like that as well. And then verify that the site time is included in the pricing that you're receiving. And also any miscellaneous hardware like scale displays, CTs, temperature probes, things like that. And then the support should be the top of any automation vendors' priorities. Some of the features that we have, let me get to the end here. And we integrate, a lot of the systems we'll integrate. So we want to avoid all those black box elevator monitoring type systems or level control type systems or any of the other, separate automation systems that are in there. Our goal is to try to integrate that into one spot so you guys have one spot or one point of support. You can call us and we'll be able to take care of the whole system that's on there. So I think, Cesar, this is a good stopping point before I started getting into some of our new features. So I don't see any questions that have showed up in the chat, but
I had a couple that have been sent to me through chat, and thank you so far. Very interesting. One of the first one is about the on the previous slide when you were showing the PLC panels and the key components. You were talking about the power the power protection device.
Yeah.
Right there, the industrial UPS, and they asking me if that also is being designed to stop high kind of high peaks of energy, the high voltage coming into the system.
I don't know. I know it filters dirty power. I don't know if it protects against surges, but I can certainly look into that and get back to you, and you can let them know. But one of the things it does is it doesn't actually just pass through the power, this particular device. It actually brings in the power, charges a battery, and then that battery is what's actually powering the output side of that UPS. So I think it does protect against surges. But I will definitely look into that for you.
Okay, very good. One on the just a quick comment. You mentioned about kind of the steps that takes to do a project, and you kind of mentioned it on the new design of the Mexico feed mill. But also, we just want to make sure that everybody understands that that's kind of the similar process for any retrofitting or any project that means adding equipment or devices to the system, and it kind of takes the same route, correct?
That's absolutely right. Yeah, we've whether it's a large project or a small project, we try to follow that same procedure just to make sure every project has the same smoothness and success.
Okay, and the last one that I have here first, you mentioned about your 24 hours support. A lot of more interest on the Mexico side, and being aware that everybody on this line, we have a package with Beta Raven of a full 24 hours service. So they pretty much available all the time for any time you need them. But one of the questions was about the Spanish support, and I think maybe I'm going too ahead of it. If you guys will talk on that, you just let me know. But it is about any possibilities in the near future of having an answering Spanish option kind of thing, so kind of can direct that phone call to the appropriate person.
Sure, we can talk about that. As most of you know, we currently have Jose on staff in our support team. Now, obviously, one person can't be that 24/7. We are still hiring, even amongst during the current conditions, and we're always looking for a bilingual support engineer. The trouble we run into is we're not just looking for someone that can speak Spanish. We're looking for someone that can do the work as well. So we don't have any immediate plans for that, other than we are constantly looking for that for all of our customers, not just the Gronhaus team.
Cesar, one other thing I would add, and that we have done in the past with some of our customers internationally, is if there's an email that can be sent in as far as a concern, we can definitely translate that. We've used Ignacio and his team have also provided translation services. If it's kind of a non-emergency type situation, but wanting to quote a change, a modification, those types of things. So we do have a lot of resources, but certainly, as Chad indicated, that is something we're aware of, and as we are increasing staffing in Fred's control systems team and customer support team, the need for bilingual engineering is certainly at the front of our list, and as we hire and continue to flesh that out, we do plan on adding additional resources there.
Very good, thank you. I think that's what I have so far. Everybody, if you had any more questions, either you can put it to the chat or text it to me, whatever makes easy for you. But thank you, Chad. We can go ahead and continue.
Sure, yeah. So so what we just talked about is everything that we've done in the past, and we think sets us apart. But now I want to start showing you what I think you came for is some new features. So one of the first things we're going to talk about is we now have the ability to do electronic signatures on the loadout ticket. So instead of signing paper, you can have one of those same pads that are kind of like at a grocery store or you know, any place you use your credit card. So in the load panel, you select your driver, and then when you mark complete, there's a window that'll appear for the viewing of that device, you know, that you would see, you know, at a doctor's office or anything. And you can see the signature shows up on the window in the computer. And then when you look at the ticket, it's got that signature right down there at the bottom, like exactly of what was signed, you know, on that electronic device. So that is incorporated into the system now. We can do that upgrade for anybody. Just need, you know, the hardware is needs to be added to the system. The next feature that we've added recently is we can send text alerts or emails to growers through the loadout system. So the first thing you have to do is in the global setups of the database is set up an email credential that you're going to use to send email in and out of. So this is up to your IT department to set this up and authorize credentials from our system to send emails. And then you go into the setups of the loadout and check the boxes for email or send text alerts. And when that is checked and a load is complete, it looks at the business entity fields for email address and text address to know where to send that ticket to. So relatively new feature. We've done it for one customer and it was very successful. But so, you know, we're looking for others to join in that. One of the most powerful tools that have been really come into popular lately is Historian for the data collection. And this is where, you know, MillMaster as a product has always been a very good data collection for the reporting needed for FDA or other government entities, but we're not collecting everything in the MillMaster product. So by adding a Historian to a system, you can collect any data that we're already looking at through the PLC or the database and combine it into one spot and bring that together into any custom report that you can think of that would benefit what you're looking for to, you know, view your business and your business needs. So data can be set up completely custom. You know, one of the things that we do with MillMaster is it's the same for every one of our customers. Well, the Historian is a way for us to customize things specific to, you know, the customers if they have something different from everybody else. So just you know, zoomed in screen of each one of these. You can see this one is a lot of the pelleting parameters put into one screen and also split screens. Or here's every temperature, bearing temperature that's in the facility, you know, viewed on one screen. So then you can kind of see if there's any one of them that are spiking. So this next feature, we are currently in development. You're getting a sneak peek. You're the first ones that have ever seen this. So what we're trying to develop is a reporting database that runs in parallel with the current automation system. And what we hope this will accomplish is, first, it'll give you unlimited potential for the reporting that already exists, but it'll also kind of solve the problem of archiving. So this database will not be archived. It'll be constantly being updated from the MillMaster system. So you can run reports against it without affecting, you know, the performance or the production of your facility in the automation system. The first tool that we're going to come out with, we're calling it our batching efficiency analysis. And the idea here is if we can get the mechanical characteristics of the batching system, and by that we're looking at the screw flighting, the diameter of the screw in batching, and we can calculate the volumetric theoretical performance of what that draw should take, and then we can evaluate, you know, look at how long did the draw actually take. We can start looking at, well, this is, you know, these draws or this dump is so far out of what theoretical should be based on your either density and your mechanical, you know, characteristics of the facility. You can start focusing in on how can I make batching more efficient by getting faster draws towards the, you know, the theoretical performance. But this is just the first idea. We think it's gonna morph into many, many more ideas. It's not quite ready for release yet. Like I said, this is a sneak preview, but it's one thing we're currently actively working on. So I want to go through some hardware ideas and features that we also have. Part of being a technology company is we're always looking at the newest hardware and technology that's out there. And with those ideas, we can come up with, features that we think will help your facility. A lot of success that we've had in the past few years has been to building major and minor scale feeder panels for facilities. And this is both new and retrofits. So what we do is we remove all the buckets that are involved in a scale and design a control panel such a way that one VFD is powering up to, infinite amount of motors really, but usually 10 to 24 motors. And this way you can add VFD control to your batching system without having to buy a VFD for every screw. Here's an example of one that was built. So this was for 8-bin scale, one VFD. Comes pre-wired with all the IO and the VFD to the contactors. You just have to run power, Ethernet, and then the motor leads land into the panel. The success of this, we've seen customers get within 1% accuracy on their major and minor ingredients. So, we're looking at the accuracy of a micro scale on your large augers and large inclusive ingredients. So part of the technology that's advancing is a lot of the devices are moving towards a communication protocol. So instead of a flow meter or a VFD that used to be controlled with various hardwired and analog signals, we can talk to those pieces of equipment with an Ethernet cable. And this provides us much faster commissioning, but we can also gather a lot more data from those devices. Integration with a flow meter is just an easy example. What it does is it eliminates the need for bucket tests. That's the biggest thing, because we can get the actual flow rate directly from the Ethernet signal instead of a pulses signal that we typically are used to, and then verifying that against a bucket scale. But it doesn't give you just the flow rate. We can also get the temperature, the density, and the volume that's going through that same device. Where we used to only get one piece of information, now we can give us anything that flow meter is giving to us. And this is the web page of the flow meter. So you can actually, from the control room, log into the flow meter itself and get all that information as well. So the same goes for VFDs. But before we used to just send start, stop, and send it a speed command. Well, now we can get back and from those VFDs, it's amps, the power consumption, looking for any fault codes so we know exactly what went wrong before a maintenance person has to go out to the VFD itself and read a fault off of that VFD. We can display all that on the system. And to dive into the Ethernet VFD a little more closely, we are really embracing and trying to sell smart MCCs, especially with new facilities. So that MCC becomes part of the Ethernet network of that facility. And with that, we can get all that information we talked about on just from one VFD from every motor. So typically in a feed mill, we're only looking at amps of the hammer mill and the leg and the pellet mill, but now we can get amps from every motor in the entire facility without adding any cost at all, really. So this is the data that we can get from one. This isn't even a VFD. This is a motor starter. So regular full voltage, single speed motor. This is all the data that we can get from one motor. So it kind of gives you your reporting capabilities, a lot larger from just was I started or did I stop, or was the overload trip. The other big advantage to the smart MCC is we remove all those hardwire signals that the electrician has to run during the commissioning of a new project, and also removes any hardware and analog signals. So this was the IO total from a brand new facility that we worked on a couple years ago. And this total was before they went to a smart MCC. So I want to highlight the outputs, the analog inputs and the analog outputs. When they went to a smart MCC, it went from 100, we had 120 less inputs, 216 less outputs, and 60 less inputs just by going to a communication protocol on all the motors. So a lot less work for the electricians and a lot more room, in your MCC room with less conduit. And it makes it so there's less IO hardware that we have to provide as well. One of the new features we've been doing in loadout as well is for shuttles and lorry scales, we've been using a laser positioning sensor mounted on in the bay that can see the, that device moving back and forth. A picture of it mounted here, there's a camera up top, but underneath this little plate is the actual laser sensor itself. I got a close-up picture of it right there. So what this does is allows for multiple size trucks, because we know the size of the truck when you start the load, and we can have that pre-programmed to know exactly where the shuttle needs to be or exactly where the lorry scale needs to be based on the truck that was loaded into the system. And this, so you don't have to have limit switches for every pocket. We can have a variable length trailer and know exactly how to load that truck without any human intervention. We've also been using RFID in both receiving and loadout. So the advantage of the RFID tag on the trailer is we can keep track of that's the right trailer that's in the right bay, or we can make sure the medication sequencing has been adhered to. So if we know that this trailer previously had medicated feed and it shows up in the loadout system, before we even load, we'll say, we haven't seen this trailer been flushed, so we'll give an alarm and won't start the load and prevent that possibility of contamination. The range on these readers is 10 feet, so it's a very powerful transmitter. So there's the picture of the transmitter, and then here's what it looks like on the trailer. That's about, I'd say, 2.5 inches by 1 inch area, so not very big at all. Can fit on any trailer just by drilling and tapping a few holes. And then once we detect which tags on there, we automatically populate the trailer ID in the load panel. There's a concept of the installation, and then a picture of the scanner that's been mounted in a loadout bay. Another thing we've been doing the last couple of years for various customers has been putting lid locks on the micro scale bins. So one of the key hazards for refilling a micro scale bin is putting the wrong ingredient in the wrong bin. So with the addition of a barcode scanner and barcodes put on the ingredients, we can verify that the right lid is unlocked when you scan the ingredient code, and that way only that lid is unlocked based on the barcode of the ingredient. The lid lock computer inside the control room, we're using the transfer panel as part of that procedure. I want to get to the screen. And then out there on the floor, we have this right next to the bins themselves, we have the picture of the ingredient that's in each one, the theoretical weight that's in them, and then which one is unlocked. The red one is the one that means it's unlocked or open. So it's a really good way to make sure that the right ingredient is getting to the right place. One of the future ideas that we have that we really like, and we'd like to see someone, take control of it, but currently for vibration monitoring, a lot of people can find a sensor that gives you the overall vibration of a machine, and which is great. It gives us an analog signal and says vibration is, this is normal. Okay, we're getting a little high, and now we're in a danger zone. We really need to look at what's going on with that machine. But it doesn't really pinpoint what exactly is wrong or what is exactly causing that vibration. So for an advanced system, we can add a little bit of mechanical and electrical data to that signal. So if we know the number of bearings, balls in the bearing, or if we know the number of blades on a fan, or the number of gear or teeth in the gear, and then we can also pair that with the speed of that device, what we can start doing is getting a more complex wave or complex signal from the sensors And what we do is we turn that into various signals based on that one signal. So we know if there's 8 balls in the bearing, we're going to get a little spike in frequency 8 times per revolution. So we can look at just that frequency and see if that acceleration is getting bigger or smaller. So when we start getting an alarm, we know it's either going to be, we can start pointing to, it's not just the machine, it's a broken impeller, or it's we got one bearing going bad, or it's the motors come out of line with the gearbox. So it's a better way to pinpoint more quickly what exactly is wrong with the increased vibration of the system. So Cesar, I think it's another good stopping point. I've got a few more slides left and we'll hand it over to Fred, but just wanted to see if you got anything else that's come in.
Yeah, thank you, Chad. Very good. I had a couple questions from our team in Mexico. One of it is about when you're talking about the ability of a VFD control multiple motors.
Mm-hmm.
They're asking a question on the addition to a same scale. If they want to add different type of additions to that ingredient scale, so they have formulas that ingredient might take, a formula might take 4 pounds, but then they have another formula that actually takes 40 pounds. And if there's any possibility to configure the frequency of addition per ingredient in that same scale.
There really isn't, because we're going to start at the fast speed until we get to the fast cutoff weight every time. Now, if your inclusion is less than the fast cutoff, yes, I think we should start in slow speed. So we do kind of take care of that in that way.
Okay. It's also asking if there's any possibility to control the configuration of the variation, mean variation high and low, if that can be configured in percent.
Yes, that feature has been added already. So if they don't currently have that, we can certainly show them how to do that, or we'll give them an update, but we can do by percent instead of weight now.
Okay. Very good. I think that's what I got so far. Thank you.
Okay. Yeah, so the next few slides are just specifically HMI innovations that we're working on. So the first one is an alarm override. So a lot of the support calls that we get are, can you disable this plug switch because it broke? We need to fix this particular sensor because it broke, and can you disable the alarm and the code so we can keep running? So what we're doing is we have it working is the maintenance, with a maintenance security level, you can disable an alarm for an individual sensor. And we do is we have it automatically re-enable every morning. That way it's not constantly disabled, and they disable it and forget about it. So every morning it's re-enabled, kind of reminding everyone, hey, this needs to be fixed. But with the maintenance level, you'll get one of these two pop-ups, depending on if it's a digital alarm or an analog alarm. And with the disable button, that will disable that alarm until the next morning at a set time. So that way you can keep running that, that area or that piece of equipment. The indication here will give you, the status of that input. So while they're working on it, you can have the guy in the control room telling, hey, it's working, hey, it's not working, and giving that feedback without having, an electrician in the panel and an electrician out working on the sensor. And then the same goes for analog. So you can now, instead of the F12 screen and looking through all that list of alarms, you can pull up the set points. You can pull up the set points of that specific device and change those alarm set points from the pop-up instead of looking through that large list of set points that are on the F12 screen, or what we call the F12 screen. Another one we've done recently is this is kind of combining the feature with putting IP camera views onto Ignition, is having a mobile driver control station for drivers to load their own trucks. So the concept we came up with was something like this, and then when we installed it, this is the view of the tablet that the driver's looking at. So he's driving and he's looking at it, and he can actually see his own truck from the camera as he's pulling up, knows exactly where to stop. And then when he's ready, in the tablet of the cab, he hits position verify, and that's when the we start loading that pocket. And then this is a short video. I have the full video I can show you guys. We were showing it at the poultry show this year. But once that pocket's weighed up, it tells him which pocket is next. He'll drive, verify his position using the camera that's on the tablet that he's holding, and then when he's ready, he hits the position verify next. So this is just kind of one of the good, many ideas you could do by integrating an Ethernet camera into the control system for better control of your facility. A feature we're currently working on and adding to the Chief mill, and we're also going to send a quote for adding this to the Algona mill soon, is the HMI replay that we unveiled at the poultry show in January. This is using a third-party Ignition license, and what it allows you to do is look back in time and see exactly what happened to the HMI screen like you're watching a movie. So you can watch all the button pushes, watch all the values change. So when you hit this button from live to the replay mode, you can change your date and time here and then hit the play button, and it's like you're watching a movie of exactly what happened at a previous spot in time. So you can try to help diagnose something that might have happened the day before or the night before as management comes in. This is a concept that we've done, and we're pretty excited about it. So we're calling it our advanced motor pop-up. Currently, when you run a motor in manual, this is the pop-up you receive. It's all you get is start, stop, jog, and if it's a speed control, you can type in your speed from 0 to 100%. But with the advanced one, we're going to put some more information on the main screen. We're also adding these tabs to the motor pop-up so you can kind of dive in and get some more information. So the first tab is a maintenance tab, and it shows you all the interlocks and permissives of that motor, whether or not those are bypassed and whether or not they're made or not. So the operator himself can even look on here and say, hey, this is why I can't start this motor. The hammer mill isn't at idle yet. We need to wait for the hammer mill to come down in amps before we can start up again. Or the motor isn't even on, or the air assist fan isn't on. And these would be customized, obviously, for every motor. So when you click on that motor, you would know exactly what's happening with that. One feature we did unveil at the poultry show this year as well was we can keep track of the runtime of every motor in your facility. It's pretty quick to add on, and you get the standard numerical values for every individual motor in the facility. And then also more for a maintenance level, but it makes it easier. Instead of navigating the F12, our typical calibration screen or F12 screen, we're adding the calibration to the motor pop-up, so that device can be calibrated directly from the HMI screen instead of going through our traditional F12 pop-up screen. And then the last tab on there is the alarms. You can see which alarms, quickly see which alarm is active for that motor as well. And then the last thing I have is about 5 years ago, there was a book released called the High Performance HMI Graphics. And the concept there was to move away from color and a lot of flashy lights on the HMI and go to more of a grayscale type system. And mainly when you look at this, you can obviously see there's, nothing is wrong, but when something is wrong, it should really, really jump out at you is kind of the point to me, a more efficient way to evaluate what's going on the screen. We've done this for one customer. It's an interesting concept. If you're interested in it, we can talk more about it. But kind of, if I go back, you can see the this bin 25 right here goes white when it's running instead of green like we traditionally do. When the gates open, they say open and they're also white, and this conveyor is running, it says running. So it's just a different way to display the same values, but in a way that only highlights the things that are bad. So that's everything I have. Let's see, I see James put something in here. Tolerance by percentage only works in the high tolerance. We desperately needed to control the low tolerance as well. James, I hear you. Fred's going to come up next, and I'll let him answer that. Cesar, anything else before I hand it over to Fred?
Yes, I got a couple more questions. One is coming from one of our MITs. And he's asking about, there is any possibility on that tab that you show on the previous slide that shows multiple options for the device, if that can contain also an information tab, that's it, the advanced motor pop-up, that if that can contain also an information tab that also can be added, like motor information, belts, sizes, or shaft sizes, or motor key parts of that specific part of equipment.
That's a great suggestion, and I'd add on top of that, let's add a button too that brings up a PDF of the manual. So if you've got a manual of that specific device, you know, we can add a button to this pop-up that brings up a PDF viewer of the manual of that device. So those are things we can certainly do. It's just the barrier to that has always been getting that information from the customer, because we don't have that information. We need to get it from you guys. So
very good. Another one is about on the loadout tablet or handheld device feature, where you can the truck driver can control the loadout and see his truck from the the mobile loadout driver controller station. Is that also is applied for every type of loadout currently in our system?
it's an add-on. It's not a standard, and it's very specific to, this one was very specific to how they were loading trucks. So part of the evaluation of a new project is, how do you plan on controlling your facility? A lot of people have different methodologies of controlling their loadout. So if it makes sense to put in cameras and control it with the tablet and a camera, yeah, we can make that part of the price of the system. But it is not a standard feature, I guess. Did that answer that?
Yeah, I guess it's the key. If any of our loadouts can add that as a feature, or request that as a feature to the system, correct?
Yes.
Okay. So one other question, going back to the data historian part of the multiple, information to keep up on the system. And when I select create features, asking, for example, tons per hour on a specific pellet line, fat application, or temperature on conditioner, can that information be converted to an Excel file or a data file?
Yes. So anything that we historize and anything that goes into the data collection can certainly be put into an Excel file. A lot of the reports that are in MillMaster currently, about 2 or 3 years ago, they added a feature that could export to Excel. But with the addition of the historian, you can certainly do any of that stuff as well.
Okay.
And I think, Fred, when you start doing your demo, just show one of those buttons that says export to Excel so they can see that.
Very good. Yes, I want to make sure as Fred is coming over, is to making sure we have the ability to get that information, especially that contains tons per hour, temperature and conditioners at the same time on the same type of report.
Okay, with that, I'll mute myself and hang around, but Fred, you've got it.
Thank you, Chad. You're a hard act to follow. Do I have control? Okay, can you see my screen?
Yes, thank you, Fred.
Okay, I'm going to run through lot tracking a little bit first. You had questions on that. Lot tracking, of course, is something that you have to tell each product that you're going to do. So first we'll go look at an ingredient and take any ingredient. You need to have a lot tracked flag. In the case of this database I've got right now, everything is lot tracked so that you can see actually what comes out of the report. Now, we've got different types of lot tracking, layered and mixed. None, of course, means you don't lot track it. Layered means it's going to be just like a pancake sitting in a bin. Mixed means we're going to take a little bit of every lot that's in that bin, and it makes for a very messy report. So I do recommend setting everything up to layered. Even though a bin is going to draw down the center, inventory really doesn't function well with the mixed, because it'll make a report that's got thousands and thousands of entries that's almost unreadable. So the key is to have everything that you're going to want to lot track, including your batching and pelleting formulas. You want to make sure you set up the lot track flag. And here is a batching recipe. And if we call up one of the batching recipes and go to the properties, you can see that we've got the batching recipes lot tracked. You want to make sure that that lot track flag is set, because nothing that, if you don't have it set, we will not be lot tracking those ingredients. And it's the same with the pelleting recipe. Go in here, grab a recipe, and you'll notice that the pelleting recipes are lot tracked as well. Then the place you can go look at the lots that there are in utilities and lots. And it takes a second for it to come up because this database has a lot of lots in it. So I'm going to take corn. They lot track everything, including their corn. We'll take a look at yellow corn, this lot of it. And we're going to track this forward. You see this particular lot of corn went into a starter feed, it went into grower feed, it went into finisher rework feed, and it went into the pelleting run of that feed. This would be the loadout tickets coming off of there. Each one of these are the lots that were created. We used that specific lot to the ingredient that was taken into us at the receiving process. It turned into these lots. These were the run numbers for the batches that used them. These are the run numbers for the pelleting that used them. And down the line, here's the load tickets that went off into the load for that. If you really want to see the detail of those lots, you click on the detail flag, and it will go ahead and tell you the time and date, what product you are making, the ingredient, the lot of that ingredient, and it will go ahead and tell you the lot that was produced there, where we sent it to, and the quantity that we debited and credited with the two lots that got switched. So this is really the meat part of the lot tracking that tells you how much was used. You can come into this, print the report, get the detailed version or just the condensed version. If you want to actually look at this in batching, we will show you that on your run summaries. the first thing you're going to want to do is look at your batch setups to see if you've got it enabled for run summaries, and this ingredient include lots on the batch summary report. If you check that one, that will allow you to see your run summary reports. Let me uncheck it first so you can see what a run summary looks like without that. See here, you're looking at a run summary. It goes with the heading information and then your ingredient draw quantities, but there are no lots with it. If I go back to the batch setup and set the flag and go back and run the summary, you see the ingredients here. Here are all of the lots that we used. There happen to be some blank lots on some of these, but if you look at your wheat here, this is a lot that we used on the wheat, the lot, the quantity we drew, and the deviations. So if you want to include your lots with a batch summary, this is how you would add that together. A little bit on HACCP. The program, it's not a bad program. It's a little bit hard to administer, but there are pieces of it that are very good. When you start developing your HACCP program, it's run by control points. So the first thing you do is in admin, you have to define what your control points are. And in this case, I've added a receiving control point and a batching control point. Control points can be multiple of them. So within sets, you can set control point sets. Here's the receiving control point set and what it's going to do. You could have, we've got one customer that runs receiving control point sets, and what they do is they check to make sure that the truck that's hauling a load of corn or something didn't haul something that was toxic beforehand. So they look at the bill of lading to see what the previous load was, and they mark that it was checked. Then to add it into a receipt, you have to go into your ingredient and select an ingredient you're going to add it to, and click on make it a receiving product. This is where I've added this receiving one to this particular control point. And it's going to that particular ingredient. So 126, 186. Once you've got this part set up, then it's all up to the receiving operator. And you're going to go in, create a ticket. And what it does is it allows this HACCP button to come up. Here's the step that would have to be verified. And the notes was step verified. Where this is going to show up is on your audit trail. So once you get that label, come into here, display the audit trail, and it'll be down here under the notes. The truck was clean and the step was verified. So that's how you know that that particular HACCP step actually flowed through the system. Any questions so far, Cesar?
Fred, thank you. I do not have questions right now. Let's proceed and then see if we get any few more.
Okay. I am going to load a new database so that I can go through some concepts that we've been working on that you haven't seen. So give me just a second.
Yes, no problem. Thank you.
Okay, we've got a concept right now that is produced to order. And the way that it could possibly help you guys is when you batch and you pellet something, you want to know the ingredient usage out of each one of those steps. But at the end of the day, you want those two steps to be added together to give you one summary total. So if you're using your theoretical fat right now and you put it in batching, you know that pelleting isn't going to use that exact amount. But the reports that are going back to your corporate are telling you use the theoretical fat amount. What you do is you produce a feed of something to order.
Fred,
yeah?
I'm so sorry. Just want to make a quick comment here because I know this has been a big point of discussion lately, and I'm glad and happy to having this meeting as well. Our head of nutritionists. I see Chris Parks and as well Alejandro. So I appreciate the joining, but as well for everybody information, this is a key point to understand the reason of why theoretical fat is now being able to separate from mixer fat in the report. So I would like for you to spend some time on that, explaining the reason and as well on what could be the potential to help us to go through this, but to see if the future of batching per order will be really will bring any benefit to that and in any way that can be done as well.
Okay. Now, the batch to order, what it really does is an order comes into the system for a given amount of feed. And in this case, we'll go look at an order that was completed. Here's a completed order in the system. It has a product that we're making. It's going to be pelleted. It's going to be batched, pelleted, and bagged. And there are a few concepts that you haven't really been exposed to in this area. Just remember that we've got an order for a given amount of finished product. What happens is that order comes in and it gets put into the mill recipe. And the mill recipe is a total of all of the ingredients in the formula, regardless of what area they get put in. It's the batching, it's the pelleting, it could be downstream ratioed, it could be anything that's used to make that finished product. So in our case, it was formula number 594 AAA 24. This is a list of all of the ingredients. Some of the ingredients, such as the soy oil or stuff, some of those are going to be put in batching. Some of them are going to be put in pelleting. And right now, what you've got is a theoretical amount that is put in batching so that the pelleting's fat gets sent back with the batching summary so you can pull your inventory from that. Now, the theoretical ingredient is it draws fat perfectly. There's no over, no under. It's purely a mathematical calculation of I made a 10-ton batch that's going to require 400 pounds of fat. You get an exact 400 pounds of fat, but it's a theoretical fat that didn't really go on at 400 pounds. This is a way to clean up that so that when we report back, we get all of the batches that made there, and we get the pelleting side that put on that 400 pounds of fat, and it really put on 386 pounds. When it comes back, the order summary is going to say I made this much and I used 386 pounds of fat that went into that to make the total amount. But what we do is we take this mill recipe, which is all of the ingredients. Seem to have some slowdown here. And we run it through the ingredient distribution. And the ingredient distribution will give us the quantity of how much goes into each one of those different positions, such as the grease. Well, we're going to put 100% of that into pelleting. So remember, the mill recipe's got all the ingredients, but we're going to take 100% of that specific ingredient and put it into the pellet formula. What this will do is it will automatically add your batch formula, your pellet formula, and any other formula down the line. And I will show you what that created. The batch recipe will be here's the 594 AA. This is all the ingredients and the mix parameters that we run for our batch formula for that one. This was automatically created from the mill recipe, so someone didn't really have to type this in. It came down as a mill recipe. We took the batching section of it and made the batching recipe. We appended a B to the batching recipe. If we look at the pellet recipe, or we appended a P to the pellet recipe because this particular recipe ends at a bagging process, something that you guys really aren't going to have, but you would make good use out of the summary that comes out of this. we automatically made this pellet recipe as well. Right now, I think you're adding your pellet recipes by hand. The way we make an automatic pellet recipe is we have a default template for a pellet recipe that we bring in all of the new recipe parameters down here for initial steam, spout temperature and everything. Once it's created, you can go change these. Your changes will stick for every next recipe that uses this. But you don't have to go create your pellet recipe by hand at this point. When all this is done and everything is batched, you get your regular batch summary, you get a pellet summary, but electronically with your data exchange, you get an order summary that has all of the usage used to create that order in one place. So this would save you from having to use the theoretical as, you know, your gospel fat usage. You can tie your actual fat usage to the product that you made. Any questions?
Fred, one of the complications in our system is a lot of larger feed mills don't necessarily manufacture by order. They typically go by, you know, inventories and what is available out there to manufacture. So I guess that can be translated by calling an order. Depends on what is projecting to make or what it's going to make for the day. Kind of
Correct.
And to be able to activate the future to separate fat from the mixer and fat from the theoretical, correct?
Correct. It's not a big jump to run by order. It's more of a thought process. Right now, as we get into the grinding orders, I'll explain a little bit more. Most integrators run grinding to just keep full. And even your batching and pelleting, right now you kind of just look at a loadout bin and you say, I need 50 tons of pellets to go into this bin, 50 tons of starter pellets to go into a bin. And that's kind of how you run the system, is you're using an internal order in your head to make this. The only step you would really need to do is to formalize that order, put it on a piece of paper, or, you know, put it in the system and allow batching to make its step and pelleting to make its step, and then process the order summary that comes out of it to get everything in their actual amounts that were used to produce the order. So conceptually, you're using an order concept that is just in your head at the moment. So just by formalizing, looking at your loadout bins and saying, I need to make 50 tons of starter, instead of adding manually to those production stacks for batching and pelleting and so on, all you would do is add 50 tons of starter to an order inside of admin orders and process it. And it would keep track of everything you were looking for, you know, to get actual usage instead of the theoretical. Just add that order right into your order system right there. Now, grinding orders, that one is kind of interesting that you brought that up. Most of the time you guys grind just to keep full, so that you've got your ground corn or whatever you're grinding. You fill up the bin, and when it goes down to a certain level, you start doing the same thing again. The same concept of our batch and pellet to order, we're creating an order to run a certain amount of product through the grinder and send it to loadout. We have recently picked up a customer that's got a product called crimped corn. Now, this crimped corn doesn't go through the batcher or any other process. They do a volumetric weighment on the tons per hour that the grinder or the roller mill puts out. They process that straight over into a loadout bin, and that gets loaded out into a truck. We do have a grinding schedule, and the grinding schedule allows you to grind to keep full, or it allows you to grind a specific quantity of product. I don't know if that would fit you, but there's a possibility of it. Interfaces right now, you had interfaces into a Dynamics AX. Dynamics AX, I assume you're changing your ERP system, or are you running that currently?
That's a good question, Fred. I will have to ask that in Spanish. Omar, ¿el IXP System es lo que estamos actualmente utilizando en México o se está pensando cambiar?
Estamos trabajando con el FMM, el GP, pero estamos buscando opciones.
Okay.
¿Sí me entiendes?
Yes. Yes. Gracias. So currently we're using the female manager, and they're looking for other options, and seems that IXP is the one closest to us to what they think we're thinking about it, but just been looking on them and just interested to know
Okay.
the possibility.
That's what I assumed. I remember you using Feed Mill Manager, and I remember setting up the system so that the imports and exports work for you there. The Dynamics AX is a Microsoft cloud-based system. And we do interface to a cloud-based system that MTech has got running on the Azure at one of the sites up here in Nebraska. But I have not interfaced to the Dynamics AX one. It isn't a Dynamics AX, it's a different ERP system. But we're willing to work with anybody to be able to work with our system. Obviously, we've got our CAN standard interfaces, which, you know, are tried and true and functioning with all the I guess they're format solutions now, Feed Mill Manager and the Brill system, the MTechs of the world, but we're always interested in interfacing to other customers. So the Dynamics AX really doesn't scare me, other than it's a little bit hard to get data in and out of the cloud. But we have done it, and I see no reason that we can't work an interface out there.
Very good, thank you. Omar, ¿entendiste?
Sí, lo entendimos. Gracias.
Okay. Yeah, thank you, Fred.
That's all I've got. I turn it back over to Chad.
Yeah, that's all. I mean, that's all we had for you guys today, unless there's any other specific questions for, I mean, really anything regarding, you know, Beta Raven or feed mills. So I thank you everyone for attending, and I hope you got some, you know, good information out of this.
Chad, I got a couple questions. One is about we currently working with trying to looking for best way to monitor, one is moisture and the other is pellet quality. I'm researching more information and working with research and development department on the kind of designing what is our what this will be as our moisture reference, as our best moisture in the process or pelleting, and how we control the moisture by having an inline sensor. No thinking about NIR, as we haven't had very success on that, and the increased amount of time and effort that system requires. Is there any other technology out there that you guys have been familiar working on moisture inline controls and also on pellet quality?
That's, whenever I talk about moisture control, it's kind of the holy grail of pelleting. If we could figure that out, I've looked at least 7 or 8 moisture sensors, and they all have the same problem, that they need to be recalibrated for every formula. You can get them dialed in, like if you're running just alfalfa, you can get it calibrated for alfalfa and get a really accurate moisture of alfalfa. But with feed mills, everyone's running a lot of different recipes with various ingredients inclusions, and it's just nobody's figured that part out. If someone can find a sensor, we would love to be able to, research with it and try to figure out a better way to control the pellet quality with it. We just haven't seen it yet.
I'll make a comment on that. This is Chandler. I would monitor the direct ground corn with moisture because it's a single ingredient. It'll be more successful that way. And then relative to moisture addition, we know the water we add into the mixer. And then secondly, and I've said it forever, but we should be metering the steam going into the conditioners. Not just using a flow control valve for temperature, but actually metering the steam. If we meter the steam, we have a much better idea of how much moisture we're truly adding. Granted, we don't condense 100% of that, but we're pretty close to it. Those would be my 2 steps that would be attainable, at least in my mind, in the next short time future.
In Chandler, thank you for your input. And actually, that's kind of our thoughts. Actually, James Neal is partnering with me on this, and we're thinking on corn. And the reason is because obviously it's 65-75% of our recipe, and it's very critical, and it's technically where pretty much our problems come from when they start having moisture issues. So we're thinking that sensor there that technically will need to be calibrated in a feed mill that only use corn and wheat maybe a couple times a year, that probably won't be much of an issue. And also, we also shared some information a few weeks ago with Jonathan Aldrich on a sting meter that we can potentially work with them and also test it for the for future kind of similar correlation on this to how we can figure this out on the moisture side.
Understood. We've been metering steam at Purdue Cofield for some time, so I'm confident that piece of it will work.
Very good. Thank you. And on the PDI, on the pellet quality, Chad, you said you don't have anything yet.
No, we will interface to any sensor, but it just hasn't been, we haven't found anything to be able to do that.
Thanks. I think that's pretty much what I got. If you let me, I don't have anything else on my phone either. So I really appreciate everybody's time. Larry, Fred, Dennis, Chandler, all those. I saw some of you reps from Mexico also on the call. I really appreciate your time and effort. One question I'm seeing right now, I'm sorry, is James Neal. He's asking if Fred can touch on the tolerance by percentage.
The tolerance by percentage, of course, we do the high tolerance only by percentage. The low tolerance, most of the time, the low tolerance is more of a mechanical issue than it is a percentage. I can bring that up and see if we want to go percentage on that, but most of the time your low tolerance is going to be in pounds or kilos. In other words, your delivery device can only deliver at a certain distance from target, and you can't get the low tolerance in the percentage. But I can bring that up again to see if you want to try it in a percentage.
So this is James speaking. When I input new formulas, looking at our batch variance, I have to go and find the lowest inclusion of each ingredient and go to the device and set that device low tolerance every time we change formulas to keep within that plus or minus 5% or our goal. So if you got a product that pulls 100 pounds in one batch and then 10 pounds in another batch, it has to use the same tolerance set point that I set for the lowest inclusion.
But it uses the low tolerance should be set to the accuracy of, or the limitations of the device itself. The high tolerance is more of a nutritional bound where if you put this much in, it's going to hurt the animals or something down the line. But the low tolerance is almost always a 3-inch auger can only deliver this percentage or this close to target. Whether it's drawing 150 pounds or 1 pound, a 3-inch auger can only deliver at a certain accuracy level. And it doesn't vary by percentage. Now, if you varied the size of the auger, that would vary by percentage. But if you're using that same auger, you're always looking for that low tolerance to be as close as possible. Now, if you're looking at different speeds, if you're willing to give up some of that tolerance and are willing to stay in the fast speed longer, then I can see a need for having 2 different tolerances. Maybe one percentage that's speed based or what you will accept, and another one that's delivery device based. Does that make sense?
Somewhat. We still, though, if I have one batch that's 100 pounds, the next batch is 10 pounds, and I want to be within 10%, I have to set that low inclusion or that low tolerance by the device at 1 pound, so that when it draws the 10 pounds, it has to be within that 1% or that 1 pound. As whereas the 100 pounds, I could get an under tolerance alarm and stop batching when I'm well within that 10% at 5 pounds.
So you're looking at getting increased speed as opposed to accuracy.
Well, both. Because if we don't change that low tolerance every time the formula changes, so we pull all our batching data every week, and it is analyzed to be within plus or minus 5% of target.
Okay.
Company-wide. And then if it's not within plus or minus 5%, we basically have a penalty cost that says, well, you didn't put the right amount of pounds in, so you cost the animal this much, or cost this much production. As whereas if it goes over, you basically use too much ingredient.
True, but that auger, that delivery device can only deliver to a certain accuracy. And our concept is always to draw to as most accurate as possible.
Correct, but
I'm going to waste time getting there.
Right, if the auger draws up and we're we come to the low tolerance, but that low tolerance is not within my 5% that I'm going to get graded on, it will accept that as long as it's within the low tolerance I've set on that device.
Correct.
Whereas if it was doing it by percentage, it would automatically know it needed to get tighter tolerance on this next batch.
I can go ahead and,
0 on every batch.
yep, I will go ahead and bring that concept up and see what everybody says. And then
I
I'll let
appreciate
you
it.
know, James.
I appreciate it.
Okay.
All right, very good. So thank you all, Better Raven team. I appreciate all your time, and I hope this for everybody else in the call, in our company, and for Mexico as well. This has been some kind of value for you, and I do appreciate you joining. I will share this email, so for anyone of those that you think is interesting for them to listen, please share it. But other than that, I really appreciate everybody, and as well you, Better Raven, and Larry for helping us to put this together and sharing the information. I think it's been very interesting. So, thank you.
Well, thank you, Cesar, and the entire Smithfield team. Again, we appreciate your time this afternoon, and certainly appreciate the years of opportunity to partner with you all, and hope to do that for many more. So.
Very good. Thank you so much. Have a good afternoon, everybody.
You do the same.
See
Thank
you.
you.
Bye.
Bye.
Thank you.
Good afternoon all, friend.